let's take a look. I'll just give you a couple examples, and then I'll move to the actual R just so you can see things. So here's the mean. I took the mean of x. X doesn't exist. So if you take the mean of something that doesn't exist, you're clearly going to get an error. Here it says, so you get the error message. This is produced by the stop function. And I call the traceback. It tells me where the error occurs. Well, the error just occurs like right away at the top of the mean function. So the function mean didn't actually call any other functions, right? Because it couldn't evaluate your argument. And so that's where the error occurs. So that may or may not be used. Many times that is where the error will occur at the top level function. So that in that case the traceback's not very handy. One thing that's useful that the traceback is useful for is for when you're communicating with someone else over email, for example, me, and you say, I get an error when I call whatever function. It's very useful if you just say, here's the traceback after I get the error. And then I can see, okay, well, what was the list of function calls? I mean, unless the traceback looks like this, then don't bother. But when you're communicating with someone about an error in a function, it's very handy to print out the traceback so that they can see kind of where the error occurred in the hierarchy of functions. You have to call traceback immediately after the error occurs. If you execute some other code and then call traceback, it's not going to work, right? Because the traceback will only give you the most recent error. If you execute another function and there's no error, well then there's no traceback to give because there's no error in the next execution. So you have to call it right away. Here's a little slightly more interesting traceback. So I called LM, which is the linear modeling function. I said y tilde x. So y tilde x, they don't exist. And so I'm getting an error that says y cannot be found. Where did that error occur? Well, actually it occurred 7 levels deep, actually. So here I called LM. And the LM function is a little funky, so I don't expect you to understand all this. But LM called eval on what's called the model frame. Then that called eval again, which called the model frame function, which called the model frame default. Model frame is a generic function. That called the model frame default function. That called the eval function again on this. And at the 7th level here, that's where the error occurred. Okay, so it occurred because it tried to evaluate my formula here, which is y tilde x. That's what all these eval calls are for. And it couldn't. And when it evaluated the formula, it couldn't find the actual values of y and x. So then that's where the error occurred. So printing out something like this can be very useful if you're trying to get help from someone else and you're kind of trying to debug your function together. Okay. So that's the traceback there. The debug function doesn't really work well in the static format like this, but I'll just show you that. But basically, I could debug the LM. So you can debug any function, right? It doesn't matter whether you wrote it or not. So I can debug the LM function. And now when I call LM y tilde x, you get this debugging in, and it'll give you the expression that you called. And the first thing it'll do is it'll print out the entire code of the function. So this is a lot longer than, so I just kind of cut it off in the middle here. But the first thing it does is it prints out the whole function body code. Okay. And then you get this little prompt at the bottom here. The browse prompt. So now you're in what's called the browser. Okay, and the browser is just like your R workspace. Actually, you can think of it as like a workspace embedded within a workspace, right? But the elements of the workspace are the environment of that workspace in the browser is your function environment. So the things that are in your function are what are in your environment. So at the very top of this function, when you just execute, there's nothing in your environment except for the function arguments, right? So what are the function arguments? Well, the first one is the formula. So I have a formula in my environment, which is this y tilde x, but that's it. Anyway, so now I can, there are other arguments to LM2 which have default values. But they're not listed there. But they do. I shouldn't say there's more than just the formula because there's other arguments. So here, what I do is I press N for next, and it runs the first line. I hit N and then enter, and then it runs the first line. N, then enter, it runs the second line. N, enter, third. I just keep hitting N, N, N until I run, and I just execute each line until I get to the line where the error occurs. So when you get to the line where the error occurs and you execute it, you'll get an error, just like you did before. It's not going to magically fix the problem by itself. But at least you'll know where that error occurred. Okay. So, and furthermore, suppose you can debug functions within the debugger, right? So you can, I can call, if I want, so I can call, so this match.call function, I just kind of stepped right over it, but I could have gone into this function by calling debug on match.call before executing it, and then when this got executed, I'd be in the third level of the browser. And so these things can nest, and then as you go out, so they're kind of like a stack of browser frames, right? So, so you can call the debug function on functions while you're in the debugger, and then so you can step through functions that even while you're kind of debugging your top level function. The recover function, so you can set the recover to be this kind of error handler, but using the options function. So you can say options error equals recover, and so that will set a global option, right? So now this behavior will occur for everything you do as long as your R session is open. As soon as you quit, it'll go away, and then if you start up R somewhere else, it's not gonna save that option. So now what I'm trying to do is I'm going to read.csv some file that doesn't exist, okay? And then you get an error, and you get the error message, cannot open the connection, and you get some warning also. And now, but instead of getting my console back, I get a little menu here. And this menu is the function call stack, okay? So it's the same thing that you would get back if you called traceback after the error, right? So read.csv is what I called. Remember, read.csv is just a wrapper for read.table. So read.csv called read.table, and then read.table called the file function because it wanted to create a file connection with my file, no such file, right? And then when it tried to create that file connection, obviously it couldn't find the file, and that's where the error occurred, okay? So the error occurred at this third level in the function call stack. So what you can do is you can press a number, 1, 2, 3, and then you can kind of browse the environment of that function. So if I want to see, okay, well, what was going on in read.csv, I could press 1 here, and then it would show me kind of the environment in the read.csv. And then I can break out of that and look at the environment for read.table, et cetera. And so you can, if you have a very long function call stack, you can kind of jump back and forth to see what was going on at each function call to try to pinpoint kind of where the problem occurs. Okay. Okay. So, so just to summarize really quickly, there are basically the 3 main indications of some sort of problem or condition. There's the message, warning, error, and of the 3, only the error will stop execution of the function. When you're analyzing a function that you think has a problem, make sure you can reproduce that problem, and then you make sure you can articulate kind of what your expectations and what the output are and how the output differs from what you were expecting, or I'd like to say what you were expectating. And so the interactive tools, traceback, debug, browser, trace, and recover can be used. And the key word actually here is interactive. The reason these tools are useful is because they are interactive. You can kind of do things on the console. And of course, the debugging tools are not a substitute for thinking. And so you should always think about writing your code before just throwing it to the wind and hoping the debugger will catch it.